Hello everyone, it's my honor to speak here on behalf of my group, and I'm very glad to share my topic with you. Before we begin, let me introduce myself briefly. My name is Kehan Liao, and I work in CCER Digital Technology Company. My team members are Dr. Zhigang, Xinyu Zhang, and Shaohua. They are from Guangzhou Institute of Energy Conversion and Minting Technology Company respectively. Today, I'm here to give a presentation on our paper, Blockchain Application in Methodology for CCER. There are 5 chapters in our paper. First, let me talk about introduction. Carbon peak and carbon neutrality become crucial environmental objectives in many countries for global warming and environmental deterioration. To achieve these goals, some small and medium-sized enterprises in China begin to build distributed photovoltaic power systems to replace traditional energy systems. This action and their other efforts on emission reductions produce carbon assets. These carbon assets can be certified as China Certified Emission Reductions, that is CCER. They can be traded in carbon markets. However, there were many problems in the procedure of certification of CCER and management of big data. Blockchains are considered as a useful tool to solve these problems. They can be used to record the whole life cycle of carbon footprints and the circulation of total factor of carbon emissions. In this article, we study the blockchain application in methodology on CCER for distributed PV power generation. Next, let's pay some attention to the definition of carbon assets and CCER. In this article, we use the definition offered by Jiaming Wang. That is, carbon assets refer to the assets related to carbon emissions under the implementation of carbon neutralization strategy or carbon trading mechanism. In this slide, I use a figure to show what is CCER. It is a kind of carbon asset. Figure 1 illustrates one type of how enterprises trading in carbon trading markets of China. The government allocates the carbon emission quotas to enterprises. Enterprises that need excess carbon would purchase surplus carbon quotas or CCER from other enterprises, so they can satisfy the requirements of governments. After clearly understanding the definition, I want to show you some existing methodologies, at least 3 common guides or standards around the world. Well, in China, there are also 3 methodologies announced by National Development and Reform Commission that can be used in PV power generation. They are suitable for different kinds of power generation. However, the methodologies mentioned above face a lot of problems when used in the measurement of carbon emission of distributed PV power generation. The first one is big data produced by a large number of small and medium-sized enterprises increases the cost of management. Second, authenticity, security, and traceability of data is hard to guarantee. Last but not least, although there are a lot of certificate authorities in the market, the certification of power generation and tradable electricity is still difficult because of complicated procedures and various kinds of costs. As a result, there is still no exchange size for SME PV carbon-related assets, though it is well accepted that such exchange will be necessary to stimulate a lot of SME PV construction, and therefore help the peak and natural target fulfillment. Before we talk about the blockchain application, I want to show the development of blockchain first. In 2008, Nakamoto first proposed the concept of Bitcoin, which applied the blockchain technology. Since then, blockchains have become widely known and experienced 3 stages of development. Table 1 describes the three stages. Blockchain 1 is represented by Bitcoin and can be only used in payments. A new decentralized and low-cost digital payment system is built by blockchain technology. Blockchain 2, represented by Ethereum, is to build a decentralized global computer which supports Turing complete in contracts, that is so-called smart contracts. Blockchain 3 is the justice, efficiency, and coordination applications beyond currency, economics, and markets. With the features of decentralization and trust, there are several movements in this stage. In China, industry blockchain is mainstream, which emphasizes to use this technology help industries enhance mutual trust and data sharing. While in West markets, DeFi was one of popular use case, among others such as social media, Web3, metaverse, and so on. In this article, we use the methodology designed for installing distributed PV power generation system in Guangdong province as an example. It illustrates how blockchains decrease the cost, simplify the certification procedure, and ensure the authenticity, security, and traceability. According to the methodology, carbon emission reduction can be calculated by the simplified equation as following. The first independent variable is electricity produced by distributed PV power generation in the Y year, and the other one is the local carbon dioxide emission factor in the Y year. The data comes from electricity meter offered by project applicants, an official document published by the National Development and Reform Commission respectively. This slide shows the procedures of the blockchain application. Based on the system of smart electricity meter, data can be uploaded to blockchain system directly and does not enter the back-office system of distributed PV power station, which makes it real-time and independent. Also, to deploy the decentralized ID based on asymmetric encryption, all data uploaded is digital signed and timestamped, which make it immutable. Next, based on the methodology, use equation on blockchains to calculate the voluntary carbon emission reduction automatically. One further implementation is using smart contracts to deploy the integration of CCER and Oracle to read the local carbon dioxide emission factor from a trusted data source, so that the final CCER asset has more credits. According to the result of last procedure, Tokens calculated based on smart contracts are sent to the address of blockchain wallets. They can be considered as carbon assets or owning virtues that can exchange to carbon assets in related organizations. Users can trade the CCER tokens on this blockchain or connect it to trading system on other blockchains. Even if the traditional carbon market doesn't accept these assets, with the reliable footprint on-chain, some decentralized trading system can be deployed quickly and enable peer-to-peer trading firstly to activate the market. Now, this presentation has entered the final stage, conclusion. The features of blockchain such as decentralization and traceability make it possible to be applied in the methodology on CCER for distributed PV power generation. The application decreases the cost, simplifies the certification procedure, and ensures the authenticity, security, and traceability. However, the construction of blockchains in carbon asset certification of distributed PV power generation is still a developing field. People should make more efforts on it to achieve the goal of carbon peak and carbon neutrality. Well, that's all I want to show you. Thanks for listening.